Assalamualaikum warahmatullahi wabarakatuh. رب اشرح لي صدري ويسر لي أمري والعقدة من لساني يفقهوا قولي. أما بعد, I hope that everyone, all of you, is in their best condition. I hope we can keep our health, stay fit, stay healthy. So for today, we will going through to the tutorial 1, where I believe all of you already try to answer all of the question given. And now this is my chance to show you how to answer the question 1 in a proper way. So let's have a discussion. Okay, now let's move to question 1. In question 1, this question is asked us to calculate the molecular mass of each species that have been given in the question. And to calculate all of the species, the concept of mole mass is a must, where we need to know which one we need to calculate first. So that is the mole mass. Mole mass is a bracket, order, division, multiplication, subtraction, and addition. So we need to know which is come first, and based on that we can get the correct answer or the correct way to calculate each species. For example, if now we have here the question asks us to calculate the molecular mass of hydrated copper sulfate, where here we do have copper sulfate hydrated. So we have copper plus sulfur, we have oxygen, also we have 5 molecules of water. So here we need to know how to calculate the molecular mass of the species. So for example here, now we need to identify. So we have copper, we have sulfur, we have 4 oxygen, we have 5 H2O, 5 molecules of water. So copper, sulfur plus O4. Why is my O4? Because we have 4 oxygen here, and so we have 5 H2O. So by referring to our periodic table, we know that the molecular mass of each species here. So for example, molecular mass of copper is 64, sulfur is 62. Now we have oxygen 4. So oxygen, the molecular mass of oxygen is 16 times with 4, because we have 4 units of oxygen in our species, plus 5 H2O. We have 2 H and 1 O. The molecular mass of H is 1 times 2 plus 16. And then we try to solve this calculation here. So now we know that this is in bracket. Then in bracket, so we try to solve it first. So 16 times 4, we get 64. 1 times 2 is 2 plus 16. So 2 plus 16 becomes 18. So 18 times 5. So that's why we have 90 here. So that's why we have 64 plus 2 plus 64 plus 90. We add it together all together, and then we can get the molecular mass of the species. So the molecular mass of the species is 250 grams per mole. So next we go to the next question. So this question asks us to calculate the molecular mass of sodium. The baking soda. So the baking soda, the molecular formula of baking soda is NaHCO3. So again, here we have Na, we have hydrogen, we have carbon, and we have oxygen, 3 oxygen. So that's why we have NaHCNO3. So again, identify the molecular mass of each species by referring to our periodic table. So Na is 23, hydrogen is 1, carbon is 12, oxygen is 16. But here we have 3 units of oxygen. That's why we multiply it by 3, calculate it. So we will get 84 grams per mole. So don't forget with the unit, because it is the unit show this unit. So that's this unit show that this is a molecular mass. So this is the unit of molecular mass. And next, question 4. This question asks us to calculate the molecular mass of tetrazine dye given the molecular name is carbon 16, hydrogen 9, and 4, nitrogen 4, sodium 3, oxygen 9, S2. So here is this the molecular formula of this compound is quite complex, but again the concept is quite same. So do not fear when you see this long molecular formula, because the concept is the same. So the molecular mass of the species is now we identify. We have carbon 60 carbon, hydrogen, 4 nitrogen, 3 sodium, 9 oxygen, and 2 sulfur. So we have carbon 16 plus H9 plus N4 plus Na3 plus O9 and plus S2. So again, by referring to our table, we need to identify the molecular mass for each species present in our molecular formula. So for carbon is 12 times 16 plus 1 times 9, and nitrogen, the molecular mass of nitrogen is 14 times 4. Sodium is 23 times 3, oxygen is 16 times 9, and again sulfur is 32 times 2. So we need to solve whatever in bracket first. So 12 times 16 we have 192, 1 times 9 we have 9, 14 times 4 we have 56, 23 times 3 we have 69, 16 times 9 we have 144, and 32 times 2 we have 64. So we add all together, so we get 534 grams per mole. So this is the way how we answer this kind of question, and I believe you can try to answer by your own question, the rest of this question. So next, let's move to question 2. So for this question, this question give a van der Waals equation, where we say is a popular equation among chemists, where we need to use it to calculate the pressure, any pressure that is given in the system. So you will see this equation a lot, van der Waals equation a lot, when you taken physical chemistry course. So the question which relates the pressure P, the volume V, and the absolute temperature T of an amount and of a gas weight, where A and B are constant. So suppose if we have 1.0 mole of argon gas occupying a volume of 25 and 10 power of -3 meter cube at a pressure of 1.0 times 10 power of 5 Pascal, and the constant A and B given, the value of A and B is 0.10 Pascal meter power of 6 mole per mole. So this is the unit for constant A, and then constant B we have 4.0 10 to the power 5 meter cube per mole. Here is the constant for, here is the dimension for constant B. So by using the board mass concept, calculate the left hand side of the equation. So the left hand side, the equation asks us specifically to calculate the left hand side. So this is our left hand side. So first thing first, what we need to do is we need to identify the information. So we need to extract the information given in the question. So we have N, we have V, we have P, pressure, we have constant A and B. So everything we can extract from the equation, from the question given to us. So next, what we need to do is we need to plug in all the number into the formula. So to plug in, we need to plug in at the right place. So for example, this here is pressure. So from here we need to identify where is the value of our pressure. So we didn't want to plug in at the wrong places. Now we have P, pressure, the n power of 2 over v square in bracket, and in bracket we have v minus nb equal to nRT. So here is our left hand side. So we plug in all the number here. So our pressure is 1.0 10 power negative 1.0 10 power of 5 plus A. Here is our A. Value of A is 0.1, and we have n. N is number of moles, so number of moles is 1.0. 1.0 power of 2 over v square. So our v here, v is 55 10 power negative 3 meter cube power of 2. So don't forget about this. Don't forget about the power of the volume. And bracket we have v minus nb. So v again, v is 25 10 power negative 3, and our n is small, is 1.0, and our b is constant. We have 4 10 power negative 5 equal to nRT. So by using our calculator, we can calculate this value. So we will have the value we will get approximately is 2.499 times 10 power of 3 Pascal per meter cube. Okay, here you also can write it in this form 2.5 because it's 2.499, so it's close to 2.5 10 power of 3 Pascal per meter cube. And so beside you also can write it, because if we convert it to power of 3, we can convert it to kilo. It will be 2.5 kilo Pascal per. It depends on you in which way that you want to write the answer for this kind of question. So that is how we answer to question 1 and question 2. So let's take a break.